Hello, in this video I'm going to talk about integrating graphs, and this should help you complete an integrating graphs assignment that you'll find below. So first off, our content and language objectives. Our content objective is I can calculate the area under a line to integrate a graph. And our language objective is I can write an explanation of the difference between distance and displacement when integrating graphs. So first off, the integrating graphs assignment. Integration is a concept that has to do with calculus, where you're basically finding reverse of slope. You're figuring out the area underneath or above a line. And so what you're going to do when you're integrating graphs, and it's shown here in the picture, is you are going to look at the zero line. You're going to look at another line that's drawn here, different line segments. And what you're going to try to do is you're going to figure out by breaking every section underneath the line or above the line into triangles and rectangles. We won't do anything with curves. What is the area of each of these triangles, rectangles, triangle, triangle, rectangles? And then you can figure out what is the total distance traveled or displacement from a velocity versus time graph. So how do you figure out the area of a triangle or rectangle? For a triangle, you take 1/2 base times height, or 1/2 your x value times your y value. For a rectangle, you just take your x value times your y value. You take the length times width. And so I wanted to go through an example, and I wanted to talk about how distance and displacement calculations would be a little bit different. And so the first step, whether you're calculating distance or displacement, would be to break some line segments here into triangles and rectangles with respect to the zero line here. And so when you take a look at the line that we have here, we have a triangle, we have a rectangle, another triangle, and I want to deal with all right triangles. And so we have two more triangles below the line right over here. And so once you've broken your graph into 1, 2, 3, 4, 5 different sections, what you need to do is find the area of each of these sections. And you're not going to use, this is 1 square and 2 squares. We have different values on these axes. And so the x value here would be 10. We're going between 0 and 10. Our y value here, it's not 3 squares, but it's 60 is our height. And so to figure out the area by a triangle, you would take 1/2 times 10 times 60. So 600 divided by 2 is 300 units, or 300 meters would be the distance that was traveled during these first 10 seconds, or 10 minutes, excuse me. To figure out the area of a rectangle, we would then just take the x value. So this is 10 and this is 20, so that would make this 15. The difference here between 10 and 15 is 5, is our x value, and our y value is again 60. So 5 times 60 is again 300 meters that was traveled in these 5 minutes. And so you would take all of these values. If we're trying to figure out the total distance traveled, you would take the values that you come up with for 1, 2, 3, 4, and 5 and add them all up. If you have a positive velocity, anything above 0, all these have positive velocities here. What you would do, what you would see, is you're moving forward. Anytime that for 4 and 5, you have a velocity that's negative, that's below 0 here, what that means is you're moving backwards. But if you're calculating distance, it's just how many steps that you've taken, like you'd find on an odometer or a pedometer. And so going forwards, going backwards, it doesn't matter. You're still taking steps. And so your distance would be 1 plus 2 plus 3 plus 4 plus 5. If you're trying to calculate displacement, though, displacement is different than distance. Displacement is how far do you end up from where you started. Positives and negatives do matter. So you would take 1 plus 2 plus 3 minus 4 minus 5. Because if you're moving forwards in 1, 2, and 3, and then you move backwards, you're moving closer to where you started. So that is how you integrate graphs, how you find the area above or below the line here, and then what is the difference between figuring out the total distance traveled and displacement. Distance, you're going to add all the numbers up. Displacement, you would subtract any negative values. That's all I've got. If you have any questions, please stop by the virtual homework virtual science homework help hours, office hours. I'd be happy to help you through this if you have any questions. Thank you very much. Have a great day.